Today we're going to talk about what makes a good nucleophile. And a good nucleophile is not as straightforward as what makes a good base. In general, good nucleophiles are negatively charged species, but there are exceptions. For example, the fluoride ion is not a good nucleophile. It is, in fact, a fairly poor nucleophile. So, what makes a good nucleophile? Well, a good nucleophile is generally something that's negatively charged and has relatively local location of that negative charge. Also, the larger the nucleophile, the better. So, for example, within the halides, iodide is an excellent nucleophile, and bromide is a very good nucleophile. And chloride is still a good nucleophile, but not as good as the previous two. Another case where the periodic trends show up is in the negatively charged oxygen family, where anything with a negative charge on sulfur, such as the HS minus hydrogen sulfide ion, is a better nucleophile than the hydroxide ion, but both are quite good nucleophiles. And the same is true if your negative charge is on sulfur and oxygen, but you have some sort of carbon group over here instead. Finally, there are some neutral things that are good nucleophiles, primarily anything with a nitrogen, and which is not quite as good as neutral phosphorus. Again, the size effect. And ultimately, the reason that some of these may not make so much sense initially is because nucleophiles, good nucleophiles, are things that make effective bonds with carbon. They're so-called soft nucleophiles in the soft-hard acid-base theory. So what you're looking for a good nucleophile is something that's negatively charged, fluorine being the exception of a good nucleophile that's negative charge, and relatively localized. Let's take, for example, the comparison of having a methoxide ion with an acetate ion. An acetate ion has two resonance contributors, so that its negative charge is spread out. And it is only a moderate nucleophile. It's not particularly weak, but it's not strong, or like the methoxide ion is, because its negative charge is spread out over two centers. So this one's strong, this one's mediate or moderate. If you could spread the charge over three atoms like the carbonate ion, it's very, very weak nucleophile. So recognizing a good nucleophile, you want to look for a negative charge on something other than fluorine, negative charged sulfur, oxygen, negatively charged nitrogen, carbon, negatively charged halogens, not fluorine, or neutral phosphorus or nitrogen. Moderate nucleophiles are sometimes have some delocalization of that charge. Weak nucleophiles tend to have a lot of delocalization or be neutral. Other weak nucleophiles we've run into are things like water and alcohols. How does this compare to a strong base? Well, strong bases are also negatively charged, but they're much more limited in their identities. For the purposes of E2 elimination, the strong bases are anything with a negative charge on oxygen that's not delocalized, negative charge on nitrogen, which is not delocalized, or negative charge on carbon, which is not delocalized. Meaning, when I say not delocalized, I mean no resonance possible. And what is the relationship between strong bases and good nucleophiles? Well, it turns out that all these things we classify as strong bases are also good nucleophiles. However, we have to always be aware that if you've got a strong base, that an E2 elimination could be a competing pathway. Not all strong or good nucleophiles are not, however, strong bases. In fact, the halogens, the halide ions, which are very good nucleophiles, are extremely weak bases.